So in this section, we're going to dive into the OWASP, and especially the OWASP top 10. So first off, what is the OWASP Foundation? So basically, the OWASP Foundation is an open web application security project, which is the synonym that OWASP stands for. So it's a non-profit foundation that is working towards improving software security, and they work with different areas. So they work open source with tools, resources. They have different communities and networking arrangement, and they also provide education and different training. But especially what has made them popular within web application security is the OWASP top 10, and that is what we're going to work with in this section. So in this lecture, we'll start the journey of getting introduced to the OWASP top 10, which is the framework that we're going to be working with in this course and what this course is centered about. So what is OWASP 10? Basically, OWASP 10 is a standard awareness document that is made for developers and web application security engineers, and it presents a broad consensus that has been made within OWASP of the most critical security risks to web applications. And this top 10 is renewed every 3 to 4 years, and as we see in this example here, this is the OWASP top 10 for 2017, and then this is the top 10 of 2021, which is the most recent. As you can see here, some of the items that were or the security risk that were in the top 10 4 years ago has now been rearranged based on how critical they are to modern web applications. Some has been removed, and then there has been introduced a few new topics in this year's on the year of 2021's version. So basically, this is changed over time, but some of the most critical and some of the most widely used by malicious users has basically stayed on the list for as long as this top 10 has been around. And if you want to take a closer look at this list, you can navigate to their webpage, so the OWASP top 10. You can find that under the owasp.org homepage, where you can read more about OWASP as a foundation and some of the other services that they provide and projects they work on. Then under projects, you can navigate to OWASP top 10. And in here, you see the image that you just saw before for the 2021 version, and then you can read in details about all the different security risks. We will dive into all these 10 risks in this course because we will be working with them actively when we get into the pen test section. But just to give you an introduction of where you can find further information or where you can see the newest up-to-date information about each security risk. And by going into them, you can read some information about how critical they are, what the expected damage is if performed successfully, and some examples of the scenarios and how you can mitigate these attacks. But we will be covering this in this section as we will dive further into each of them. So see you in the next lecture. So the first in the top 10 is the A1, broken access control. And what is broken access control? Well, broken access control is when a given user, for example, in a web application, can act outside of their intended permission. You can, for example, imagine that in Facebook, if a malicious user somehow get access to act as another user on their behalf, he can actually communicate with the other user's friends. He can like and post as that user, and then trick, for example, people that he is friend with, that he trusts, to give him information that he can use to further exploit. Or he could ask them to transfer some money to him because he is in dire need and just need a few $100 to get out of it, and thereby using that user's trust between the friends to escalate that into further malicious activity. It could also be, for example, on a web shop where typically there is an admin page to add goods or modify prices and different stuff. If a malicious user can get access to that admin page, he can manipulate the entire web shop and change prices and the stock information and basically all the data on that site. So that is when broken access control is being manipulated. And examples of that is, of course, evaluation of privileges. This is the example that I mentioned, that you are acting as a user without being logged in, or you are acting as an admin when logged in as a normal user. So this Facebook web shop example. Then there is also CORS, misconfiguration, where APIs allows access from unauthorized or untrusted origins. So API should only allow access or calls to come from a trusted origin, such that it is only from that particular source that the request is being processed. Then there is the violation of the principle of least privilege, or deny by default. And this basically means that users or anyone in general in the system should never have access to more data or information than they are in need of. And if they have, that can be manipulated. For example, if you have a company where, for example, the receptionist have access to the Git repository just based on the standard privileges when you are hired in a given, when you are working in a given company, there is no reason for her to have access to that repository, because she's certainly not coding, she's a receptionist and doing other tasks for the firm. But if she's getting compromised and she have access outside of her required work area, she can be used to further escalate this attack and compromise the company. So always ensure to have people only give them access to the specific task that they are working with or data that they are in need of. So this was example of the broken access control. You can see more examples on the OWASP.org webpage. Then we have some of the examples to prevent and mitigate this. And of course, one of the main ways to prevent and mitigate this is that you should accept for the public resources, for example, in web application. Of course, users are in need of getting access to the web page, meaning that all the files that is needed to load and display that page in a working way, that should be available for the public users. But all resources apart from that should be denied by default. There is no reason for anyone to have access to other folders or anything on that particular web service apart from the folder where those specific files are stored in. Then we have the log access control failures, where you are repeatedly or constantly logging when someone is entering, for example, wrong credentials, or you are alerted whenever an admin permission is granted for a given user, because there should never come a new admin unless the department that controls the admin are actually providing it. If they are not giving an admin privilege, then there's certainly something wrong. And by logging, for example, repetitive failures, login attempts, you can you can see that somebody is definitely trying to do something malicious if you get 100 wrong login attempts on a given user, because typically a normal user will either have the password, or after a few attempts in regular systems he will be blocked after that, but he will then request a new password. And you can see that, for example, a brute force attack is on the way if you see a massive amount of login failure attempts. Then there is another way to mitigate broken access control, is to rate the limit from APIs, such that you can control how many times a given source can use your API. And in normal scenarios, a given API shouldn't be called like multiple times a second if it's from regular use on a given web page. But if you see something out of the ordinary, then there is definitely something wrong. And by rating the limit of the API, you can limit the automatic attack approach, where a given user is just bombarding your API with different requests and different parameters to see if some of it work. But if they are limited to only make, for example, 5 calls every 10 seconds, then that will take tremendously longer than if they could execute 1,000 calls in 5 seconds. So these are some of the ways that you can prevent and mitigate broken access control. And of course, you can see some other ways as well to mitigate this, again by visiting OWASP.org. So this was the first on the list. Next off, we will move to the number 2 on the OWASP top 10. Next off, we have cryptographic failures. So cryptographic failures is switch shifting up to position 2. in the OWASP top 10, meaning that if we go back a few slides here, you can see here, before it was considered as sensitive data exposure as number 3, but in the most recent top 10 from 2021, it has moved to the top 2 position from being number 3. And basically what this security risk is all about is the fact that sensitive data is not being encrypted, meaning that it can be exposed, or traffic between sources is encrypted, either not encrypted or encrypted in an unsecure way, such that people can get access to the data. And some examples of this is, for example, where you have to ask yourselves, are password being used as cryptographic keys in absence of the password, or are they basically being stored? For example, any system that just store passwords directly in the database is having a major issue on their side, because then if a user get access to the database and that table where the passwords are stored, he or her can read that in plain text. Whereas if the passwords are hashed, for example with a salt, then there is nobody that can actually read the password in plain text, not even the owners or developers of the site, because the hash is a one-way function. We will dive into hashes later on in the course, so you will get to know what this means. And another example is when you are using depreciated hash functions. So for example, if you're using a hash function that is easily cracked or is computational wise easy to iterate over a lot of times, then you are also at risk. You should always, as a developer of a site, be sure to use the recommended and standard algorithms when it comes to encryption. And these change based on computational power over time, such that new algorithms come forth that is stronger. So even though that some algorithm might be secure now, there is no guarantee that these also will be secure, especially not when quantum computing become a thing. But that's a topic for another course. And then also another example is that the received server certificate, is that from a trusted chain, and is that being validated properly? And if you're not aware of certificates, for example, every website, if it's over HTTPS, which most websites should be today, have a certificate that allows you to communicate securely over the HTTPS using this public-private key pair abstraction. So for example, Google, you can watch their certificate by clicking on this little icon right here, the log icon. Then you can show certificate, and here you see that the google.com page that I'm on right now is having a valid certificate, and the certificate change is these two certificates that is this determined as the certificate author of this certificate. So this is a certificate chain, and that has to be validated properly, such that you are sure that the certificate on the site is not just being has not been issued by an untrusted source. So let's get back here. And then how to prevent and mitigate. A few examples is, for example, never to cache responses that contain sensitive data. That should never be cached anywhere, not on the user's page by you programmatically having set cache for that, or in the backend. Then you should avoid legacy protocols such as FTP and SMTP. You should never use those for file transfer. There is secure protocols for that. And then there is don't store sensitive data unnecessarily. So if you have some sensitive data that is not needed or no longer needed, that could be credit card, personal data, then you should not be storing it in your database, because if you store it and you are not using it, it's just there to wait for somebody malicious user to access it and make misuse of it. So this was about cryptographic failures. Next up, we will look into injections. So the next of A3 is injection. So injection is when an application is vulnerable to injection attacks. For example, in a web application, there is a lot of user inputs for a web application to work, unless it's just a simple display page where you display some information for the user to read. Most web applications have some kind of input fields that could, for example, be common fields, user register forms, or any type of input elements where a user is asked to provide some or can provide some data, because if that data is directly sent to the backend and stored in the database without being, for example, validated or filtered or sanitized by the application, then there is a high risk that malicious users will try to use these input fields to input malicious code. So instead of writing a given comment, for example, I like this video, they will try to inject into the text field a SQL query that they know a given web application that is vulnerable to injection will react on. So that could force trick the application to fetch data from the database and display it front end for the user. So without them having direct access to the database, they can manipulate the backend to display information that they are not allowed to see. It could also be when users are injecting JavaScript into a comment field that is then being displayed, for example, in a comment field to other users of the page. Because if the page is then not filtering or validating this properly or sanitizing it, then you risk that they can use a given input field to make cross-site scripting attack where other users on that page will execute that particular code whenever that comment is being displayed for them on the web page. So injection is a very common attack approach that is seen in web application, and that is also why it's number 3 on this list. And we will dive into how to perform injection attack when we get to the pen testing section of this course. For more about the injection, then you can visit the OWASP.org page, as always. So next up, we will look into insecure design. So A4 in the OWASP top 10 is insecure design. And insecure design is not one single risk or weakness in a web application, but it's more like an approach to how you develop web applications. So insecure design is a broad category that represents different weaknesses or express missing or ineffective control design, whereas secure design is more a culture and a methodology built around the way that you build web application as a software engineer, where you constantly evaluate different threats and you ensure that the code that you write and design lives up to current standards. And this is not something that is only like done once when you build, but that is continuously to be done whenever new functionality is being added or new versions of libraries or patches is being applied, because you constantly need to be aware of the threat landscape if that changes or new vulnerabilities is being discovered. And a way to ensure that you have secure design and thereby preventing insecure design is to, as a software developer of a given web application, is to establish secure development life cycles, and you ensure that the libraries that you are using within a given web application is truly tested and is like being used widely across the industry that you are building within. For example, if you're making a Java application, you ensure that the libraries that you're using is current standard for the given functionality that you want to implement, and not something that is not used by many people and just developed by some random guy that made a library, because then there is a high risk that since this library has not been truly tested and used by like multiple developers, that it contains flaws or security failures. And then it's important that you consistently evaluate the threats that is available for your application and evaluate how your web application could be attacked and what weaknesses it might consist of. And that is also what we are focusing on here in this course, how we can continuously evaluate this, for example, by using pen testing as a tool for doing so. Next off, we'll be looking at security misconfiguration. A5 is the security misconfiguration. So security misconfiguration is one of the most common seen issues out there when you are dealing with web application or online services in general. And that also applies, of course, for configurations in infrastructure settings and so on. And the result, security misconfiguration is a result of incomplete or just ad hoc configurations. For example, when you are spinning up an environment, that could be, for example, a cloud environment, you don't take the time to look into what firewall rules are set up, how is the network traffic being allowed, or what IPs are open. Is the web server open for the entire internet, or is some default port open that you are not actually using on the web page? If you're only having traffic over port 80, there's no reason to have other ports open. Hopefully your traffic will come to port 443 due to the HTTPS. But there is a lot of standard configuration when you are setting up different resources in the context of an application, and if you don't take the time to configure these probably based on the application that you are hosting or what the intention of the resource that you are having, then you risk having security misconfiguration that is vulnerable to certain types of attack. It could, for example, also be that the server or one of the hardware is running software that is not patched, meaning that it has vulnerabilities that is widely known to the general public. But since you are not looking further into what version is running on this particular what software version is specifically running, then you risk having security misconfiguration. And basically a way to prevent this is to ensure that, for example, all your environments is the same. This means that you are testing both on, like, if you have a testing environment and a production environment, you ensure that all the environments that you are working on is the same. It has the same version of each type of software running, such that when you are pen testing on a test environment, you know that whatever vulnerabilities you find there will also be present on the production environment, and vice versa. Then you limit the amount of components. You should only have the components on your servers or in your application that you actually need. There's no reason to introduce components that is not used, because it's just another door for the malicious people to step into. And then you should avoid, or will be very aware of, automatic environment creation and validation, meaning that you should, if you have automated environment creation, it should be based on environment parameter setup that you have verified. So you have validated that how the way that this environment is set up is correctly based on certain parameters, and it's not something that you have just done by clicking a button and saying, I need this, for example, cloud server, just give me a random Linux server, and then you don't do any further validation on what has been created. You just deploy your web application and that's it. So it's important to be aware of how the setup is on all the different levels in your application setup, both from the system security perspective, the infrastructure security perspective, and in this case, especially the application security aspect. So this was A5. Next off, we'll move into A6. Next off is vulnerable and outdated components, and that very well relate to A5, which we just discussed, is the security misconfiguration. So where we in the security misconfiguration had a way to prevent or mitigate this misconfiguration by saying that we should not have any components that we are not using in our application or in our server setup or application environment. Then A6 is about vulnerable and outdated components that we actually use. So you have to know all the versions of the different components that you use, and that apply both for the client and the server side. Because if there, and there will for sure, comes a day where a given vulnerability is discovered in a component that you use in a certain version, you need to right away be aware of, is this affecting you? Do you need to patch your version because of this vulnerability? Because sometimes vulnerabilities are discovered in, or this is the most common case, are discovered in previous versions, so not the newest one. And since a lot of people and developers don't regularly patch their systems, then they are vulnerable to these vulnerabilities that are found in previous versions. But there is also cases where people find vulnerabilities, so-called zero-day exploits, in the newest version of a given component or library being used. And then it's up to you to know right away, are you infected, and what should you do in such situation? Because it might be that there goes a few days before the vendor or the developer of that particular library or component release a patched version. So you might need to take some active actions until a patched or a new version of that library or component is being released. And that basically applies for your entire application environment. And then it's also important that you do regular scans for vulnerabilities in your entire application setup. And this is one of the things that we will also look into in the pen testing, how we can scan our application for vulnerabilities that is known, because there is applications out there that can do this automatically, that will scan on publicly known vulnerabilities in a lot of famous libraries. So since the malicious users will for sure be using such tools, it's also a good idea on the other side, being the developer or owner of application, to use similar techniques to stay on top of possible security risks. So A7 is identification and authorization. This has previously been known as broken authentication, and it is the area where you permit, or your application permits, that automated attacks, for example credentials stuffing, is allowed, such that they can try to brute force your application using a random list of valid usernames and password that could be from a list from previous hacked applications, where the top 10,000 popular username and password combination is tried against your application. And this basically also applies to some of the topics that we have discussed before, with the default configuration or security misconfiguration, where you have allowed well-known passwords to be used. For example, if you have login to something in your application landscape, that could be on the server side or on the front end, if you have an admin page where there exists a user called admin, or simply that a user can use password 1 as a password. So whenever you are in a situation where a user or yourself is in need of identification or authorizing themselves, and you have implemented it in such a weak way that it can fail, and even though that you try to use best practices, it's often hard to do this right without proper experience. So this is a very important topic to be aware of when you're doing pen testing on your application before deploying it, that you ensure that you have done what you can, or at least use best practices in order to avoid this being misused. And there are several aspects to this, and for example, this could also be limiting the rate on the API that is to validate whether this user is to be allowed, and different kind of stuff that you can do. But an example of how to prevent this could, for example, be to implement multi-factor authentication, similar to, for example, the Google Authenticator app, where you not only have a password and a username, but also have a code sent to the user's mobile or to a mail, where they then need the mobile or the mail in addition to the password and username, because then if someone is able to crack the username and password, then they can successfully log in, because they are missing this last factor of authentication. So this will make brute forcing a lot harder. Then there is the fact that you do not ship or deploy to production any default credentials. So for example, don't submit any code to Git or your code repository where you have passwords in. That could, for example, be password to the production database. Don't put that into the code repository. And then also make sure to implement password checks, such that users are prevented from using some of the most famous passwords in data breaches. And it's easy to get a hold of such list. Some of them can even be found on GitHub, where you can get a list with 10,000 most popular username and passwords, and then you could implement a functionality that just tests against this, to ensure that if a user tries to use one of these username or passwords, they are asked to pick another one, because it's simply too weak. So this was identification and authentication failures. Next off, we'll go into A8. So A8 is all about software and data integrity failures. So software and data integrity failures is related to when you have code in your application, or that your infrastructure is not protected against integrity violations. So basically, when integrity is being violated is, for example, when you rely on a certain plugin, you have some libraries within your application or in the infrastructure, or modules that come from untrusted sources, as mentioned in security misconfiguration. We also had this in vulnerability and outdated component. So this is kind of related to what we have discussed previously. But for example, if you have such element from repositories or, for example, content delivery networks where you rely solely on somebody else delivering the code for your application or infrastructure to work, if you don't validate what you're using, then if some malicious user or the original creators of the component or module is either making a flaw by mistake, which makes your application vulnerable because you rely on their software or component, or it could be that a malicious user has succeeded in infiltrating their network, and then they post or get access to inputting malicious code into that library repository. So whenever they update their repository, if they are not aware that they have been infiltrated and there has been inputted malicious code, they will just publish that version, and since you trust the source of that library, you simply just fetch the new version of that component and thereby get the malicious code. We have seen several examples of this in real-world scenarios where hackers had succeeded in inputting malicious code that were then distributed to 1,000 of applications and systems. So a way that you can mitigate or prevent this is to always use the digital signatures to ensure that whatever library or component you have is the original one that were released by the creators of it, because a signature will be unique for that particular code. So if something is inputted in transit, then the signature will change and you will see it right away, since your signature will not match the signature that they have posted for you to verify. And then also be sure always to only use libraries, components, plugins, anything that you are not developing yourself, and only use that from trusted sources and trusted organizations. And then of course you also need to ensure that the libraries and dependencies are coming from trusted repositories and not from some random guy that has just developed something that has a similar name to what you were looking for. You need to be aware of that there exist libraries and dependencies out there where they have a similar name to something very popular, because then people in some cases will download the other component by mistake. So be aware of what you fetch and use in your application and how you verify that when you're updating it, that it is a original and trusted entity. Next off is A9, where we'll look into security logging and monitoring. A9, security logging and monitoring. So logging and monitoring of what is going on in your application landscape is what helps you detect, escalate, and respond to an active breach or an breach ongoing. So when you are not having proper logging or monitoring, you cannot detect a breach. So you have no idea of what is going on, and since you don't know what is going on, you can't escalate and respond to it. This means that you will probably first find out that you have been hacked or something malicious has happened when data or the application is either taken down or being misused. So some of the often seen things that can lead to insufficient logging is that you, for example, don't login failures. So when people are trying to brute force your applications, you are not sufficiently logging messages, warning messages, error messages, meaning that you can't have a clear understanding of what they mean or what they relate to. You have only stored your logs locally, meaning that if someone succeed in breaching into your system, they can basically just delete the logs that stored the information about how they got into the system. And if you're not actively logging all the aspects of your system, not only the application but also the network and basically the entire landscape, then you risk having an vector that you are not aware of. And if that is used to breach your system, you will again not detect it and you will not be able to respond to it. Some of the ways that you can prevent or mitigate this is to ensure that, of course, all attempts to use your APIs, for example, login, anything is being logged. You ensure that the logs that you generate is in a format that you can easily put into any log management system. That could, for example, be Splunk, such that you can easily search and make advanced queries to detect a trail in what has happened or what is currently happening. and then you also ensure that your logs are stored in a way that prevent them from being manipulated or deleted if a breach is successfully being executed, because you need that trail to investigate what has gone on, what has happened, in order to mitigate against it and close that gap which the attackers use to get into the system. These are just some of the things that can be used to mitigate against insufficient logging and monitoring. There is others as well, and I again recommend that you go into details, go into OWASP.org and watch the details of some of the common attack vectors that is being used for this, an example of how this can be misused. We will again in the pen testing section of this be using some of the attacks. Here we will not be focused on the logging and monitoring, so we will not actively cover setup of logs in the landscape, and this also is the result of that it's hard to say which is the best way of logging or what logging management solution you should use. It depends entirely on the stack and also on the software that you're using in your application landscape. So based on what you're using for your application and what stack you're using, try search the net for best practices within that given stack to ensure that you have the best possible logging of your system and you're using recommended approaches, for example, recommended logging management solutions. So next up, we'll dive into server-side request forgery. So last off in this current top 10 of OWASP is server-side request forgery. Remember that the OWASP top 10 is updated every 3 to 4 years, and the current version that we have been gone through in this section is from 2021. So remember to keep yourself updated, because it's not necessary that the top 10 will look similar when it's get updated next time. Certainly something will move around, either to a higher position or something will be taken out and something new will be taken in. It depends on how the threat landscape look at that particular time. But server-side request forgery is basically when for example, a web application is fetching resources from a remote source, and that is typically happening when you have a dynamic web page that is in need of fetching resources from a backend. That could be user information, that could be items in a web shop or something similar. So whenever you are having a direct transit of data with a front end and a backend, you are in risk of having server-side request forgery, because if you don't sanitize and validate all the input that is being inputted by a client, then you risk that your server will actually put out or access some information that the user were not allowed to use. And if this user in this case is a malicious user that is using the device of a real user is accessing, then he can actually bypass firewalls and VPN, because that particular device is allowed to make that particular request. So it's important that you, for example, disable HTTP redirection such that all communication in transit is encrypted, and that you do not send any raw responses back to the clients, and then that you enforce URL validation such that the port and URL that is giving to the server is validated against a whitelist, ensuring that only valid URLs is being allowed on a certain port. This to avoid that the user or a malicious user can start to probe your backend or your servers for potential open endpoints that were not supposed to be accessed from the outside. And since this is being executed from a trusted source, these might get through anyways, and thereby giving access to something that this particular user or malicious user should not have access to. So this concludes our OWASP top 10.